there are 5 fundamental skills, okay? So first of all, you need to learn how to write code, right? You need to learn how to write code. Of course, when your code has problems, you need to understand how to test your code and correct the mistakes from the code. So that's obvious thing. And you need to document your code, right? Put the comments, write your code in an easy to understand manner, this and that. And also, if other people write code, you should be able to understand, right? Because we write code, when in the software industry, we need to collaborate with other people. If you don't understand other people's code and how they're supposed to work, how are you supposed to collaborate, right? So that's why, the analysis of code behavior is very important. Now, we often just don't jump into write code. We are given a problem, right? So from the problem, you have to do a design, right? Problem solving with design and algorithm. So we're gonna learn those as well. So those are the 5 elements, key skills we're gonna pick up, right? In order to score 5, you're gonna excel in each and every area. Do this, variables.
Hi, in this lesson, we're going to look at variables and data types. In the last lesson, we learned about one data type called a string literal, which is a sequence of characters that are enclosed in double quotations. In this lesson, we are going to learn about more data types that exist in Java. In addition to strings, there are several other data types that are used to store data: ints, doubles, chars, and booleans. Each type has a set of values and operations associated with it. We can use these data types the same way that we use strings to print output to the console. In addition to printing, these data types can also be stored in variables. So what is a variable? We can think of variables as a box with a name that stores a value. All variables have a name, type, and a value. In this example, the variable named numapples has a value of 5, which is an int data type. In order to create a variable, we need a value of 5, which is an int.
So here I pause. So sometimes you just think logically, why a variable has a name and has a type, right? So because you want to refer to this variable, you want to have an easy to remember name to refer to it. That's why it has to have a name. Why it has a type. I give you one example. Why apple has to be int? Int means integer, right? Why apple is not a float? Float means a real number. Why apple is not a string? Just think about that, right? Clearly, you can have 5 apples. You cannot have 5.2 apples, right? So if we really want to talk about 5.2, you're talking about apple cider, right? Maybe 5.2 pounds of apple juice or something, right? You're not talking about apple, always count by pieces, 1 piece, second, right? Has to be integer, right? So just think about the name and the type.
Okay? Data type. In order to create a variable, we must declare the variable in our program. There are 2 key components to declaring a variable: determining the type of data that is going to be stored in the variable and naming the variable. We can determine the type of the variable by first writing the name of the data type we want stored in the variable. In this case, we want to store an int value as numapples. Once we've determined the data type, we can then name our variable. Variable names should be written with intention and should offer some insight into what is being stored in the variable. Let's take a closer look at some guidelines to follow when naming variables. When writing variable names, it's important to follow appropriate naming conventions. Variables must start with a letter, $, or underscore. If variables are named starting with a number, it will cause the program to throw an error. Although the beginning of a variable name cannot include numbers, the rest of the name can. The naming convention we will use in this course is called lower Camelcase. Essentially, the first word of any variable name should be written in lowercase, and every subsequent word should be written with the first letter in uppercase. For example, variable name with the capital N would be an acceptable variable name, but variable name with no capitals or variable name with a capital V would not. This is mostly to make the code more readable to programmers. It's important to note that variable names are case sensitive. This means that upper and lowercase characters are not equivalent and are treated as different values. If we have a variable name with a lowercase n, it is not the same as name with an uppercase n. When writing variables, it's important to match the exact spelling so the correct variable is being called. Once our variables are declared, they can then be initialized, which means that they are assigned a value. An important thing to note is that the data type in the declaration must match the assigned value type. In this example, an error occurs because 5 is an int type, but
this is like you're trying to put a square into a round hole, right? So you can't do that. It won't fit.
Variable has been declared as a Boolean. In order to get this declaration to work, we would need to either change the data type to int or the value to a Boolean type. Variables can be initialized at the same time that they are declared, or they can be initialized after they have been declared. Both statements will create a variable named numapples that holds the value of 5. Once variables are initialized, the values can be changed by setting the variable to a different value. Variables can be protected from alteration if the keyword final is included before the data type. If there is an attempt to change the variable value, then an error will be called indicating that variable has already been assigned. This is often used as a security measure in more.
So basically we talk about declaring a variable, right? Integer, not the type and the variable name, and you can instantly initialize the value, or you can initialize the value later by adding an extra final in the front. It's just the value is assigned up front, and you are not allowed, or anyone else is not allowed to change the value later, right? But at this moment, it may not be too important.
Complex programs to ensure that values cannot be modified by others. Now that you've learned about the basic variable types, let's get some practice using them in the editor.
Okay, good. So let's also quickly do some of these, okay? Okay, first one I give to Steve. Which of the following is a proper way to declare and initialize a variable in Java? Blah, 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 blah. Which one is correct?
C.
Correct. So it has all the components, right? You have the type, you have the variable name, and then you got. So again, put easy to remember name, okay? Don't put variable 1, variable 2, variable 3. I mean, it's Java will not tell you it's wrong, but it will be very confusing. Yeah, but at this moment, it's okay, right? It has all the components. Here, there's no type. Again, this has no type, right? And again, you may say char is a type, but then there's no variable name, right? And here it's missing both. Okay, good job. Then let's give this to Jeffrey. Consider following code snip. Okay, blah, blah, blah. You see, it actually, you say, hey, where's the class definition? It doesn't matter anymore, right? We assume it's there, okay? So we're saying final into z. Oh, this seems interesting. So Jeffrey, which one is correct?
Won't the code give an error since there's 2 values?
No, not for that reason. Not for that reason, but definitely give an error. Because if you put final, you have to define the value together with it, right? Because it does not allow you to modify this value anymore. Logically, how can you say final without initialize the value? Jeffrey, that makes sense?
Yeah.
Right. So you must initialize value here, and after you initialize the value, then you cannot change the value anymore. So anyway, this example is very wrong for many different reasons, right? So yeah, choose this is correct, but you just happen to state a different reason. But yeah, good job. So let's do Steve again. What are the memory values associated with variable x, y, and z after code snip blue execution? Okay, so let's see. So again, we're not talking about the void domain, and we're not talking about class definition, but it's fine, right? We just only talk about this guy. So okay, this is 7, this is 2, this is false. X, okay, yeah, okay, yeah, I understand now. Which one, Steve?
None of them say like Boolean C. Oh wait, wait.
I was about to say that as well. Then I changed my mind.
Is it A?
No, it's not A.
Is it C then? What?
Oh, it's
actually B. So let's check this one by one, okay? You see, this initialize the value, right? If this thing never happened, you can literally, you just check this value against this. If this never happened. Now, this happened, right? Okay, so this change X, so X become 10. Z become true. So it's 10, 2.0 true, right? 10, 2.0 true. So let's check. 10, 10, 10, 10, okay, 10, 10. 2.0, 2.0, 2.0. True, false, true, false, true. That makes sense? Right, so this, all you do, you need to calculate, say, is now X equals to 10. X. So this is an interesting statement, right? So we are taking the value of X, okay? So if you are in a math class, you're gonna say, what's happening? How would X equal to X plus 3? Is it infinite? No, we're in a computer science class, okay? We are saying, take the current value of X plus 3 and give the value to X, okay? So X was 7, right? We get the 7 out, plus 3, that's 10, and give the 10 back to X. So X equal to 10, right? And clearly Z is given to true. So that's why you're looking for 10. You never change this value, did you? You never. So it's 10, 2.0, and true. Then you just compare, right? All these, only B is correct answer. Steve, which of the following variable name follows best practice naming variable? Okay, interesting. Okay, which one is the best variable name? And tell me why.
D.
Okay, so what's wrong with this one?
Because it doesn't have the classification, just like 5, just the number there.
The first character cannot be a number.
Yeah.
That's why, okay, pay attention. First character cannot be a number. So what's wrong with this? What's wrong with this apples num? What's wrong with this?
Because it's the wrong way. I don't know what's in that.
No, it's a Camelcase, lower Camelcase, right? You should say apple. This S need to be, this N, apples num. This N need to be capitalized, right? It's almost like writing your name, right? So my name is Alex Sun, but I have to put this, right? So if I write email, my name is like this. But in Python program, I'm gonna say Alex Sun. So first of all, there's no space. Okay. Second, I'm gonna make the first character lowercase. This is called a lower Camelcase. Yeah, pay attention to details. So that's why you need to, from time to time, go back to the videos. Now,
Wait. I have a question.
Yeah.
So the only problem with number C is that it didn't follow the lower Camelcase.
Yeah. So that's true. What's wrong with it? It looks very healthy. So Java will not tell you it's wrong. It's only say less idea. It didn't follow best practice. Didn't follow best practice. It doesn't mean your program crashed. Okay. It means less than ideal. You have 1,000 reasons for it to be less than ideal, right? So this will definitely crash. 5 apples. Your first character has to be a character or what? I don't underscore or something. So you better check the video again, okay? But have a number is obviously wrong. This is correct. This is less than ideal, right? So now the question, what's wrong with this? It's less descriptive. That's why I told you, why don't you write a program called variable 1, variable 2, variable 3? So then you don't know what's going on, right? If your program has 100 variables, it's not rare to happen, right? And how can you read your code? It's impossible, right? You can't do this. Talk about different data types in Java, okay? Different data. So, behind the scene in the computer, everything stored in the computer is number, okay? And what are those number? But behind the scene of number is kind of, you use computer, you know the concept of bit, right? A bit is like a switch, it's on and off. Depends on the on and off, it represents 2 values, right? 0 and 1. But if you have 8 bits, it can represent 256 numbers. I will explain a little bit later why is that, okay? But basically from mathematically, right? If you say it's like 2 times 2 times 2 times, it's 2 to the power of 8, right? Because there are 8 switches. So you can represent 256 numbers. Now a char is 16 bits. Short is a short integer. All these are like integer, okay? Short is 16 bits. So-called integer is 32 bits. Long is 62 bits. We're gonna talk about this more later. A float is a real number. It's 32 bits. A double is 64 bits. All these are numbers, okay? So double specifically. So if you don't remember all these, no worry. Just remember, double is a number. Double is a number type, okay? There are different number types in Java. And the double, it's 64 bits. Typically, it represents what kind of number? It represents like a 1.0, 2.3, right? So 0.0, it represents something with the 小数点. Oh, okay, something like that. Integer always talk about a number without 小数点, right? It's like a 67. So that's why I say, hey, you have how many apples? You're gonna use this, right? You're gonna say, hey, you're gonna say, what? I clicked this, it's good. So when you have too many apples, you maybe say, I use long, right? 32, you can describe, 2,000 million apples. If you still think that's not enough, you can even do the long, right? But if you talk about something like percentages, right? Or you talk about the distance from Earth to Moon, you're not gonna use the integer or long, right? Because it can be, because it has fractions, right? Maybe 2.3, maybe 1.05, right? So that's why you need to use double.